Hello 108 class, Mr. McHugh back with you on page 3 of section 8.4. Going to wrap this section up with combining like radicals basically, and this section here, example 3, we're dealing with taking radicals, taking square roots or cube roots of radicals with fractions in them, and we're allowed to go ahead and separate the numerator and denominator. We did that a couple sections ago, so I just recommend that you take your time, look at the square root of 75 divided by 16, break it down. Can you take 75, break it down into 25 times 3? You're looking for those perfect square roots. That's your driver right here. Okay, 16 is a square root. It's going to be perfect, so that's fine, nothing to change there. I like to show how I'm going to break them down. I take 8, I broke it down into the square root of 4 times the square root of 2. 32 I broke down into the square root of 16 times the square root of 2, because 16 times 2 is 32. And then I turn around and I look and I go, can I simplify things? And one of the things I notice is square root of 2 divided by 2 is going to cancel out, and square root of 4 is 2, square root of 16 is 4. 4 divided by 4 cancel out. Okay, so just take your time there, show your work. Square root of 25, I execute the radical. The result is 5. 2 times 5 is, before I do this, 10. 10 divided by 4. Maybe a better way to do that here, get the same answer, is 2 divided by 4 is 1/2, so that goes out once, that goes into 2, and that leaves the 5/2 times the square root of 3. Now, you might think, well, this answer looks pretty good to you, but the book really wants you to put it all underneath one common denominator. So you see the fraction in the denominator's got halves. Look at the whole number, just convert it into an improper fraction and go, if you need halves, 2 would be written as 2 over 2 is 1, double it, so you get 4/2. And then you've got a common denominator, so add them up with the 2 in your denominator, so 5 times the square root of 3 plus 4 is your final answer on that. Okay. Okay, that's about all I could say about that. I don't know. I think I don't know. The book likes this underneath one common denominator. It's just it's a protocol format thingy. That's all I can tell you. So make sure you follow that and read those directions on the answers with the little blue parentheses, and they tell you how to format. Okay, I've said this before, but that'll save you a lot of frustrations if you read how they want the format. Okay, let's look at example B here. We have got cube roots. That's the first thing I notice here. So I'm going to go in cube root mode. I'm going to take my time. I'm going to break apart the numerator and denominator. So I've got the cube root of 5, the cube root of x to the 6th. I just like separating things out to start with. It might look like an unnecessary step, but now it allows me to focus. And cube root of 5 I'm leaving alone. The 10 I'm bringing down. And then I'm looking at the cube root of x to the 6th. Remember, that's the right hand L rule. You rotate. I need to make that video here. I'm going to do it here pretty quick. So you take the index and the exponent, you raise it up, and it's 6 divided by 3. The answer is, and when you execute the radical, it turns out you drop the radical. 6 divided by 3 goes into the exponent. Okay, we've covered that before, so hopefully you're okay with that. The cube root of x to the 9th. When you rotate, you've got right hand L rule, rotate up. I wish you could see my hands. I'm doing it right now. 9 divided by 3 is what? 3. So when you execute the radical, the result is x to the 3rd. Okay? And we look at that and you're like, okay, now what am I supposed to do? Then they need to have a common denominator. Now you go, what am I supposed to figure that out to be? Now when you're dealing with a variable, x squared and x to the 3rd, if I multiplied both sides of the over here on x squared, if I multiplied it by x, I would have x squared times x to the 1st would give me x to the 3rd, and that's going to be my LCD, or common denominator. Okay, so how did I figure that out? You got to pick the exponents that's the highest. You got to go high on this. So I left the x to the 3rd alone, and I took x to the squared, I multiplied it by x to the 1st all over x to the 1st. Again, that equals 1. That's what this note's all about. So it's equivalency, but that allows you to write one common denominator, x to the 3rd, and then up at the top in the numerator in the first term you've got 10 times x times the cube root of the 5th. Okay, and over here you've got 3 times the cube root of 4, all underneath or all over x to the third. Okay, so be careful with those. There'll be a couple in there to just watch. Make sure you have a common denominator. That's the big requirement here. Okay, well, folks, class, we've done it. 8.4 is in the books. Give yourselves check marks on that one here if you've been working with me on the videos. I hope we're cruising along here with chapter 8. So now we're going to go ahead and I'll see you on the next video for 8.5. We're going to multiply and divide radicals, so we're going to work on those, and I will see you then. Okay, take care. Bye.